Here we have the polynomial p of x equals 20x cubed plus 8x squared minus 5x minus 2. And we are to find the rational zeros using the rational zero theorem and our graphing calculator. Our constant term is -2. Our leading coefficient is 20. So our zeros will all be of the form p over q, where the numerator is a divisor of -2 and the denominator is a divisor of 20. So on the top this time, we just have 1 and 2, but on the bottom, we have 1, 2, 4, 5, 10, and 20. So I'm going to start listing these using the 20 in the denominator. So 1 over 20, 2 over 20 is 1/10. Then when I move to the 1/10, we already have written that down. Then 2 over 10 would be 1/5. Now we'll move to 5. 1 over 5 is 1/5. We also have 2/5. Now we have 1/4 and 2/4, which is 1/2. Then when I go to 2, the 1/2 is already there. 2 over 2 is 1. And lastly, when the denominator is 1, 1 over 1 has already been written down. That's 1. 2 over 1 is 2. So I think we have 16 possible rational zeros, the smallest of which is -2, and the largest is +2. So it should be sufficient when we choose our x min and x max to use -5 and 5. So I've already entered the function in the y equals screen. Go to the window and enter -5 for x min and 5 for x max. Draw the graph. And we can see that the activity is happening between plus and minus 1. So I'm actually going to go back to the window, enter -2 for x min and 2 for x max. Press graph again. All right. So when I look at this in this window, it looks like we have a zero of multiplicity 1 at approximately 1/2 and a zero of multiplicity 2 at approximately -1/2. So that's the assumption that I'm going to go with. Let's start. I'm going to start up here in the top left-hand corner with my synthetic division. So I'm going to use 1/2 first. as my divisor. I'll copy down the coefficients, 20, 8, -5, and -2. Half of 20 is what we're going to do in the second step, but first of all we copy our 20 because it will be the leading coefficient in the quotient. Then half of 20 is 10. 10 plus 8 is 18. Half of 18 is 9. 9 plus -5 is 4. Half of 4 is 2. And we do, in fact, get a remainder of 0. And so now let's try the -1/2. $20 will be the leading coefficient in this quotient, times -1/2 would be -10, add 18 would be 8, times -1/2 would be -4, and add 4 would be 0. So far in our list of actual zeros, we have 1/2 and -1/2. My conjecture was that -1/2 had multiplicity 2, and so notice what this last quotient is. 8 would be our x to the 0 in this factor, and 20 would be the coefficient of x to the first. So the related factor would be 20x plus 8. It is equal to 0 if and only if x equals -8 over 20, which reduces to -2/5. There is a third completely different 0 here. -1/2 did not have multiplicity 2. There were 2 zeros that were very close together. We've got -0.5 and -0.4. Let's go back to the graphing calculator and see if we could have seen that by coming into a smaller window. So let's go to the window. I'm going to come into -1 and 1 for x min and x max, and I'm going to use -1 and 1 for y min and y max. It's still very, very hard to see that we have 2 different zeros on the left side of the y-axis. It looks as if we would need to go down to a window of maybe, let's do -1 to 0 for x min and x max, and for y min use -1/10, and y max use +1/10. There, we can see it there. But you've got to be very careful about making assumptions with these types of questions, because -2/5 was on our list as well as 1/2, but we might not have thought about using it.